Hi, I'm Stefan, and I'm the organizer and host of the emBO++, the next level conference for embedded software developers. The talk you're about to watch is about how to select a correct operating system for your embedded application. It was given by Colin Walls at the emBO 2021, and thanks to Leica Geosystems, you can check this talk out for free.
Okay, so hello everybody. My name is Colin Walls. I work for Mentor. Well, actually, Mentor is part of Siemens now, so the Mentor name is going away. I'm going to talk about selecting an operating system for an embedded application. This is a surprisingly big subject, actually, and it's interesting to even think about why we need to select them. But we'll start looking at the details now. Initially, here is the agenda for what I want to look at today. Um, After a brief introduction about why we're selecting an operating system and so forth, we'll then do a couple of things. Initially, I'm going to consider the possibility of building one's own operating system versus using a commercial product, or an existing product is another way of saying it, I suppose. And then I will go through in more detail some of the criteria that you might apply for selecting an operating system. Then I'll say a few words about Multicore because that's pretty important. Then we can wrap up, and then there'll be time for questions. If you have any questions, a good way of entering them is on the chat window on the left-hand side, and I'll endeavour to come to those later in the session. I have a 1 hour slot. I don't expect to be talking for 59 minutes of that, so there should be plenty of time at the end for questions. So, first of all, some introductory comments. First of all, there is rarely a situation when you need no operating system on modern embedded applications. If we sort of look at the scope of different applications, we can plot a sort of graph. If you look at the horizontal axis, here is the complexity of the software, and the vertical axis is the complexity of the CPU, or the power of the CPU, if you like, which is broadly measured in bit size 8, 16, 32, 64 goes off the top here. And we can divide this into 4 quadrants, really. And we can take those in turn. So if you look at the bottom left-hand corner, we have a low-end processor running simple software. And then you move up to the right-hand corner, we have a high-end processor running complex software and the other combinations. If you have a high-end processor and you're running complex software, it's almost a no-brainer to say you need an operating system of some kind. And that's the area we're mainly concerned with today. On the other hand, if you've got a low-end processor running a complex application, it's still well worth considering using at least a simple kernel of some kind, because it's a very good way of organizing your application. The other way around, if you've got a high-end processor running simple software, you might think there's no point in using a kernel. And that would be logical, except that software has a habit of evolving. There'll be some point at which that software gets more complex. You'll need to add functionality to it. If you've got a simple application on a high-end processor, well, somebody's going to want to use that processor power at some point. So the advantage of using a simple kernel now is if you build a multi-threading architecture, it's relatively scalable. You can expand that architecture in a straightforward way to a more complex application. So moving horizontally across the graph is possible. And likewise, the previous example of using a low-end processor with complex software, if you move to a higher-end processor, then you've already got the multi-threaded model and you're in a very good position to do that. The only place where I'd say you probably do not want an operating system at all, or something very, very, very simple, would be a low-end processor running very simple software. You might have a run to completion kernel here or something like that, but nothing too fancy. We're making the choice. There are quite a wide range of options. I first started putting together this talk because I was asked by a number of customers at various times, how do I make that choice? What they wanted was some kind of flow chart where you just go through a series of questions and it pops out with the answer at the bottom. It's not that simple. It's kind of interesting that for most people, most of the time, they do not make a choice of operating systems for computers because what is the choice? You can have Windows, you can have Mac OS, you can have Linux. That's more or less it. There's very few other options available which are realistic nowadays. That was not true in the past, but it is now. Embedded applications are different to desktop because every embedded application is different, so the needs of operating systems are thus different. So we can look at a wide range of options. We seem to have some company here of a canine nature, but that's not at my end. So somebody is impinging on this. I'd ask them to mute if they could, please. So we have a wide range of options available to us, and this includes high-end operating systems like Linux and variations of Windows, less used nowadays. And we have real-time operating systems, which tend to be smaller and aimed at, as the name implies, real-time applications. And the third option, we have the possibility of developing our own operating system in-house. So those are the options we need to investigate. So we'll start out with that last one, the possibility of creating a kernel and operating system in-house versus spending money on a commercial operating system. Now, this actually is quite a big subject because there are many quite well-known companies who have invested a lot of resources in developing their own operating systems. Most of them are in a position that they regret that choice now, and that can cause them some interesting difficulties. But it often looks like a good idea. I want to talk you through some of the pros and cons, and maybe you'll see where the best route is. So let's start off in a positive vein. What are the advantages of a commercial operating system? I don't mean any specific one. I mean, in general, if you're thinking of getting an operating system, what's the benefit of putting your hand in your pocket and spending money? Well, firstly, you're probably looking at an established, reliable product. At least you'll only be smart if you are. And there's plenty of operating systems on the market. And sorry, somebody's interrupting. If they could mute, please. Kind of questions you might ask are, who is the supplier? How big are they? How mature is their product? And is there a very large number of people knowing about that product? So in other words, can you get staff to work with it? And lastly, what is their support like? These are all questions to ask, and you should expect pretty positive answers to these with a well-known product. The next thing to think about is you're looking at long-term commitment. You're going to use this operating system probably for a long period of time. So you're likely to want to move, for example, to different processor architectures. Whose problem will that be? Well, what you don't want it to be is your problem. So if you have a commercial product, they will be motivated to keep up with technology. They'll have designed their product for portability to achieve that goal. Documentation. It's a good idea to see it. Once upon a time, if you'd asked a salesman to show you some documentation, he'd say, well, it's quite expensive to ship these manuals from California or whatever. No excuse anymore. They should just email you a PDF. Because if the documentation is good enough, then they should be using it as a sales tool, because good documentation should help sell their product. So if you get any resistance to asking for documentation, you might wonder why. The question of whether source code's available is interesting, because a lot of people like to have source code. It adds to the documentation, if you like. And also, is it readable? Source code should be, if it's made available to you, it should be readable, it should be well commented, it should be a useful resource to have. There is at least one vendor that does supply source code by default, but it's scrambled so you can't read it. It just suits them from a configuration point of view to give you source code. So you need to watch out for that. And of course, if somebody says they can supply source code, they may want extra money for that. That's not an unreasonable thing to ask for. You just need to know upfront, that's all. You need to have debugging support. Debugging in a multitasking environment requires certain specific kinds of functionality. And the kinds of things you should be looking for is the ability to run in what's called stop mode. That's where you put a breakpoint, probably a task-aware breakpoint somewhere, and when you hit it, everything stops. The other option is run mode, where you hit a breakpoint in a particular task and that task stops, but the rest of the system continues. Neither of these is better or worse on the other. They each have their own places and something you might want to look out for. Beyond the kernel, you have other stuff, middleware in general. So we might have communications protocols, and if you do have them, you ought to check that they are validated. There's no point in having a particular protocol supported unless you know it will talk to other devices using that protocol. And the only way you can be certain about that is when you buy a protocol stack that it has validation certification. The file that you might want a file system, flash file system most likely. You might want graphics. All of these things, if you want them, are likely to be available in a commercial operating system context. And lastly, hardware drivers. Connecting the operating system's function, one of the functions is to provide the layer between the application code and the underlying hardware. So you expect support for standard devices, and you expect the means of producing support for custom hardware you might have. So those are all the things you can realistically expect from a commercial OS vendor. So what are the disadvantages of a commercial operating system? Well, there might be ongoing license costs. There might be. It depends on the license model. Every embedded system is different, so those differences are both technical and commercial. So a commercial product needs flexibility. What I mean here is, for example, if you are shipping MRI scanners, you probably turn out a small number each month. If you are shipping cell phones, you ship thousands, hundreds of thousands perhaps every month. Your licensing needs on an operating system will be quite different. So, for example, royalty-free might be nice, where you pay a single fee up front for a design and you do not have to pay a penny for each item you ship. For other applications, paying a few dollars each time you ship something is actually good value. You want the flexibility. So this can be a disadvantage, but it needn't be. The lack of internal knowledge is what many people cite as a drawback of a commercial operating system. But one question is, do you need that knowledge? Can you afford to have it even? The example I would cite here is very simple. If I go to my car and I lift the hood of the car and look where the engine is, there's a big plastic cover over it, and there's a sticker on the cover that says, do not remove this cover because you do not know what you're doing. Well, words to that effect. Fair comment. I more or less know how an engine works, but I have no knowledge of how to maintain it. It's best that I leave it alone and let the specialists deal with it. And that's probably true for you as well. If you're not a specialist in operating systems, let the experts deal with it. And of course, the question is, if you have no internal knowledge of a commercial operating system, if you've got the source code, well, you could develop that knowledge if you needed it. Some people are worried about being locked into a particular vendor. Well, from a vendor's perspective, I would want to lock you in as a customer. However, that's pretty hard because the APIs to operating systems are really not that different, and there are standards available, so that gives you some vendor independence. POSIX being the obvious one, but there are some others. And the last thing that people complain about is excess functionality. Now, excess functionality is all about scalability, and we will look at that. Scalability is the ability of the operating system to have functions included or not as necessary. You're buying all the different functionality when you buy a commercial operating system, but that cost is spread across hundreds, thousands of customers. So therefore, you're not really buying something you don't need in general. And you'll probably have optional components like the file system or graphics and so forth, and you'll only buy what you need. A couple of words about scalability. It's a word that's bandied around a lot, but for most real-time operating systems, we're looking at fairly fine-grained scalability, which means that you might, for example, have an operating system with, in my example here, 271 service calls available. I invented that number, but it's quite realistic. So imagine we have a simple application which only uses 3 of those service calls. What would the memory footprint of this application look like? Well, we would expect it to have the application code, obviously, another chunk of code, which is the operating system. That would include the core of the RTOS, so that's the scheduler and stuff like that. And it would include the code for service calls 1, 3, and 157. What about the other 268 service calls that are available? The answer is they were never taken out of the library. They're not included in the target. That's what scalability is all about. So the target memory image contains the code you need, nothing more, nothing less. What about custom operating systems? So creating your own operating system. What are the advantages of it? Well, one advantage is control. You only have control if the staff who created it stick around. And software engineers, well, do they stick around? Sometimes they do, sometimes they find something better down the road. So you're very sensitive to that situation. It's also a very specific skill set, designing and supporting an operating system. You won't have any ongoing license costs. That's true. I'll give you that one. Of course, an advantage might be that because you've created it, what you've got is an exact match to your requirements. I would argue that what you've actually got is an exact match to what you can afford to do, because there'll be a limit to how much functionality you can develop, and that might well limit your capabilities rather than it matching exactly what you need. Disadvantages of a custom OS. Well, the first one is development costs. This is something that eludes many people because often the development costs are lost in other projects. There is no single budget for creating the operating system, but code costs money to develop. It takes time. Time is money. And the fact you've lost that cost is neither here nor there. It was still there. Long-term support is a disadvantage. As I said before, what about staff retention? The long-term support of this operating system will be a problem if you don't have that expertise there, if the documentation isn't up to scratch. I'm sure the engineers in your company all document their work beautifully, in which case that's great. You can support things long-term, but that is not always the case. Debug support. I mentioned with the commercial operating system, you expect to have RTOS-aware debug. So that's information about tasks, task-aware breakpoints. Creating such debug support can be incredibly expensive. It might even be 10 times what it costs to create an RTOS. You might be able to adapt an existing debug tool, but nevertheless, that's still effort that will be done for you with a commercial product. One of the biggest problems is creeping elegance. I will tell you a brief story. There was once a young embedded software engineer who was going to develop an embedded application, and he concluded he needed a kernel. He had no idea about the idea of buying such a thing, so he created, in a 2 or 3 weeks work, he made a nice little kernel to implement his product. That all went perfectly well. The product shipped on time, everything was great. Project number 2 comes along, so the engineer takes his kernel that he had before, he's had some new ideas, so he added some enhancements to it, and he uses the new enhanced kernel on his number 2 project. Everything was successful again. Number 3 project comes along, and he looks at it and thinks, right, my kernel will be perfect for this. I'll just add a few more enhancements to it and use that on this new application. Now, at this point, and everything went well with that, at this point, you probably want that engineer to fail because he's just having too good a time with his stream of successes. Well, what happened next was a bit of a surprise to this engineer because somebody decided that his number 1 project of these 3 needed some maintenance. It needed some modifications. So he got out the code and he took a look at it and he said to himself, oh, well, what is this kernel? Because over the couple of years of this story, he's created 3 different kernels. And in due course, that engineer left the company to do other things, leaving 3 kernels behind him. Now, I tell this story very coherently because I was that engineer, and I was doing what seemed best to do the job. If I had licensed the kernel to start off with, I would have left behind one kernel with a load of documentation on the shelf. I didn't leave too big a mess, but I did document it fairly well. But nevertheless, that's something which was a potential problem which I didn't know about at the time. So you create an operating system. You might also need to create all the intermediate components. That's an unlikely possibility. Anyone will port pieces for you. You might have to write your own TCP/IP stack. It's getting more and more expensive. If a new architecture comes along, you'll be in trouble because you've probably written a lot of your operating system in assembly language. You can run into all kinds of difficulties because you've got a new architecture. You translate the assembly language, the endianity, the byte order might be different. Interrupts are bound to be different. Lots of things which will make it hard. The last of the disadvantages of custom OS is core competencies. It's good business practice to focus on what you do well. The example I use here is, can anybody tell me where in the world Ford, the motor company, makes their paint? Well, the answer is Ford does not make paint. Ford buys paint from paint companies. Ford is a car manufacturer. That's their specialism. They buy paint from paint manufacturers. That's their specialism. If you need an RTOS, buy it from an RTOS vendor because that's their specialism. Core competency is a good way to run a business. So that's the comparison between in-house and commercial operating systems. I now want to move on to look at how we would select an operating system, having decided we're going to obtain one from elsewhere. And a commercial operating system may not be a proprietary operating system. It might be an open source one that you're going to invest in because you still need to spend money on the support and so forth of it. So it doesn't really make any difference whether it's truly commercial or actually an open source with some kind of support. There are a series of questions we can ask, and we'll work our way through them. They aren't a linear sequence. So the first question is your application real time? Now, real time does not mean fast. Real time means predictable. It means it's you can predict how long it will take to do something. It will respond in a known way in the time domain. An RTOS is likely to be best if that's the case. Not all applications are real time. You just need to decide whether they are or not. Sort of machine control and stuff like that always would be, whereas if it's very operator centric, it might not be. There are real-time Linux extensions which make Linux something of a possibility, but to be frank, Linux wasn't designed to be real-time, so I'm a little skeptical. So next question, is your memory size limited? Unless you've got a lot of memory, the heavyweight operating systems like Linux are unlikely to be a good choice because they do need certainly many, many megabytes of memory. Is your CPU power limited? Same applies. If you've got a relatively modest amount of CPU power, then you need to consider the efficiency of the processor, of the operating system, and RTOS will always score. Is power consumption an issue? Well, the power of the CPU is important, and the amount of memory will affect the power consumption. So if you can get away with a lower power CPU and you can get away with less memory, then you will use less power. And therefore that would favor an RTOS over a bigger operating system perhaps. And many operating systems include some kind of power management. Linux does, and many RTOSes do as well. So that's something to look out for if power consumption is a particular issue to you. Do you have any weird peripheral devices? Well, most RTOSes have a good range of middleware and drivers. Linux has more. Linux has a massive array of possible drivers, almost anything you can imagine. And there is a lot of Linux driver expertise around. So if you need a specialized driver written, then you can probably find somebody to do it for you. Incidentally, if you're looking at buying communication protocols, make sure they're validated. I mentioned this a little earlier on, but I don't apologize for repeating it because it's very important that only validated protocols can you be certain they'll talk to other devices with the same protocol. Do you have a memory management unit, an MMU, or could you have one in your design? If the answer is no, then the likes of Linux are not really an option, as Linux needs an MMU. whereas most RTOSes do not need one. If you do have an emBO available, well, maybe Linux is a possibility then, but actually a number of RTOSes can still take advantage of an emBO if it's there. Even if they don't require it, they can take advantage of it. What about application security? Security is all about protecting one task from another, and there are various ways of dealing with that. Process model is very effective. Now, process model is what's used by the likes of Linux. It needs an emBO. Some RTOSes actually have a process model of some kind as well. But the problem with process model is because it's remapping memory each time you do a context switch, that takes time. That's an overhead. There is an interesting intermediate possibility, sometimes called thread protected mode or lightweight process model, supported by some RTOSes, and this uses the emBO to protect memory rather than remap it. So that gives you the protection element to a significant extent with a lower context switch overhead. So that was security. What about safety? By the way, security is all about protecting a device from the world. Safety is all about protecting the world from the device. So if you need safety certification because you're working in that kind of industry, so aerospace and medical, for example, you will need some kind of certification. There is all kinds of standards you need to comply with. This is an expensive, time-consuming process. You will need source code for everything, including the whatever operating system you've got. The cost of doing certification relates to code size. So the more code you've got to certify, the more it will cost you. And it's good to choose an OS with a track record of being certified. You need to certify the entire software application. So you can't just go and buy an operating system and it's been certified, but you can buy ones where a lot of the work has been done for you. If you need interoperability with enterprise systems, then the Microsoft products tend to be quite good, although not used so much nowadays. On the commercial side, are the selling price and shipping volume for your application known? They probably are, because when you're developing a new product, you must have some idea of how many you're going to sell or what you're going to sell it for. This affects what licensing costs are acceptable. It might mean a royalty is good, it might mean royalty-free is appropriate. So if you're producing very high volumes, you probably want royalty-free, but if you're producing very low volumes, it might be more economic to pay as you go along. Now, open source is attractive because open source is free, isn't it? It's not free. Open source is attractive for lots of reasons, but bear in mind that the maintenance costs are ongoing and cannot be ignored because you can't just deploy an open source operating system and then forget it because the code is constantly updated, there are security issues and so forth. So maintenance cannot be ignored. That is an ongoing cost.
Wir sind hier in einem kleineren Grossraumbüro.
Bei den Leitern habe ich die Freiheit, dass ich, wenn ich anfange und wenn ich höre mit dem Arbeiten, eigentlich selber einteilen kann.
Overall, how I will do it, it's just up to me and they give me a lot of freedom.
Für mich ist die Faszination, mit anderen Leuten einen kreativen Moment zu generieren.
Great colleagues, great environment basically.
It's really nice here and I don't have any issues living here.
Am meisten schätze ich in den Leica Geosystems, dass wir ein sehr junges Team sind, sowie dass ich auch meine Arbeitszeit in einem gewissen Raum selber bestimmen kann.
And I could merge my life hobby with my office job.
Das Besondere an der Leica Geosystem ist sicher die Kultur und die Dynamik, die es gibt in dem Team. Es ist jeden Tag ein bisschen anders.
We have good organization which will help you to get used to the company in the first couple of months especially.
Das ist sehr interessant und ja, macht mir Spaß.
Other soft criteria are things like, does your team have experience of other operating systems? Now, if they do, then they might know the APIs. That gets them up to speed quickly. If they know POSIX, then that gives you a choice of operating systems because a number of operating systems support POSIX. If you have experience with another operating system, you may have experience of their tech support, which could be a positive or a negative experience, I guess. And the experience of documentation and source code, again, could influence your decision. I say both positively and negatively. Don't underestimate the importance of these factors. If you know that a company is good to work with in the past, then there's a good chance they'll be good to work with in the future. This can't override your technical decisions, but the technical decisions shouldn't override this either. Coming towards the end of the formal presentation here, I want to talk a bit about Multicore, because embedded applications using multiple cores are becoming more and more common. So we need to make sure that we understand the operating system requirements. So in Multicore, we have different hardware and software architectures. From the hardware perspective, we can have a homogeneous multi-core. This is where we have multiple CPU cores, but they're all the same. Or we can have heterogeneous multi-core, where there are multiple CPUs, but they're all different. And there is a sort of middle ground, a hybrid, where you've got lots of different CPUs, but maybe a number which are similar to one another. Then we have the software architectures. And here we have broadly two options. We have SMP and AMP. SMP is symmetric multiprocessing. This is a very simple idea in certain respects. You have a single operating system and it runs over multiple cores, allocating work to them accordingly. This is what you get on desktop computers typically. This can only be done on homogeneous multi-core. All those cores have to be identical. AMP, asymmetric multiprocessing, on the other hand, each core runs its own operating system. And this can be done on homogeneous or heterogeneous hardware. Now, with SMP, the OS is distributing the work across the cores. It needs a specific SMP OS variant to do that. And a number of RTOSes are available in SMP form, as is Linux. Say the heavyweight operating system have this option, and so do some RTOSes. AMP, cores all run, may all run the same OS if that suits you, but you have the freedom to choose the OS for each core individually. And that gives you the opportunity of optimizing the functionality of each core. It's a big subject, and I can't go into it in detail today, but verification and debugging of multi-core, multi-OS applications is quite an interesting challenge, because you do need other components as well for inter-core communication and stuff like that. As I say, that's a much bigger subject, which I don't have time to explore today. We'll look at a few conclusions. There is no simple answer to OS selection. People wanted a flowchart. I can't give you one. You need to take some careful consideration of the technical issues, the commercial factors, and your own experience and that of your team. And no one of these can override the others. So if you make your technical decision and you arrive at a particular product and that company has a terrible reputation, then you're probably not making a good decision. But equally well, even if the company's great, if their product isn't technically what you need, that would be a bad decision. You need to balance all these factors. Every system is different, so that's why a choice is necessary. That wraps up the main part of the presentation. I do have something else I want to talk about briefly. But here is my email address if you need to contact me, and you can have a copy of my slides if you want them, for example. There's also the address of the blog that I maintain, where I talk about embedded software and other stuff that's on my mind. The other thing I wanted to mention to you is this book was published a few months ago, earlier this year. It's been worked on for a little while. Embedded RTOS design is all about what the title says. So it's looking at how an RTOS is developed, what's inside an RTOS, and hence gives you insights into how you might use one. In fact, there is code in here for a hypothetical operating system which you could implement and use in your design if you want to. It's available from all good booksellers, as they say. It's published by Elsevier Nunes. It's at the top of one of their imprints and can be bought directly from them as well. So you've got the ISBN at the bottom there. This another piece of information on this slide, top right-hand corner, is my personal email address. The reason I include this is that the presentation I'm just completing now is actually the last presentation I'll be doing in my role at Siemens. And the reason for that is I will be leaving the company to retire next week. So this might even be the last presentation of a technical nature that I do in my career, which is a bit of a worrying thought, as I've been doing it a long time. The upshot, though, is if you need to contact me anytime after early next week, my personal email at the top there is the way to do it. And I'd be quite pleased to hear from you. So that completes what I want to talk about this afternoon. So I can stop sharing my screen at this point. No, I can leave that there. Oh. So I think I am still audible at this point. So if you have any questions, please enter them into the chat window. I'm going to have a look at what's there now. Let's have a look. So there are a few comments here and a few questions. So the first one is, what about the middle ground of advancing an open source OS in-house? So in other words, instead of implementing your own operating system, take an open source one and enhance it to match your needs in-house. That's an interesting idea, and I find the idea, frankly, rather scary, because you'll be taking some code where you don't understand all of it, unless you take a lot of trouble and expense, and by modifying it, you're making it unique. So getting support from anybody else would be pretty impossible. And if new versions of the open source operating system come out, you won't really have the opportunity of using them unless you carefully design a system whereby you can roll in the new versions. That's getting too horrible to think about. So I'm not going to even think about that anymore. It's not an approach that I would recommend. I can imagine certain very specialist applications where it might make sense. And an example of that, without wishing to go on about this at great length, is I mentioned my book, and in there is the code for a very small, simple kernel, which is perfectly possible with that book in your hand to understand exactly what's going on. So if you were to take that and enhance it slightly to fit your needs, that wouldn't be a big deal, because that isn't a kernel that's going to be modified in the near future. It will give you a good basis for something relatively simple. But I'm not backtracking on my original attitude there. Let's move down the list a little bit here. Yes, is it standard to get quick fixes for security vulnerabilities in TCP/IP or HTTP stack in small RTOSes, or do vendors tend to ignore that? No, I don't believe the professional RTOS vendors would ignore anything of a security nature. So whether it was in the kernel itself or in the middleware, you should expect to have updates there in a timely fashion, particularly when they are security oriented. Anything else here? Oh, another sort of statement and sort of question here. Somebody says, I think update possibilities should become a more prominent factor in OS choice. What are your thoughts on that? That's a very good point. And this is really all about long-term support. If you're using a system from a commercial vendor, you need to be certain that they are serious about business. Have they been in a long time? Are they good at support? And therefore, are they going to update the software as and when needed to fulfill changing requirements? This includes simple patch updates for fixing security problems, as well as perhaps more major changes as technology advances. So it's a perfectly reasonable thing to ask the guy who's trying to sell you an operating system, what's your history here? How long have you been doing this? How often do you release updates? And do you have any specific plans that you can share? That kind of thing. So it is an important factor. And if when you're making your selection, you're chatting to a sales guy and he hasn't got a good answer to those, it's probably time to walk. I didn't comment, but there's about 200 real-time operating systems on the market. So you actually have quite a choice, although a lot of them are a bit obscure and a bit specialized. But don't think you're locked into just a very small number. So where are we time-wise? We have a bit more time. So if you have any further questions, then the chat box is a good place to put them. And what I'll do when I've finished with this, if there are no more questions coming in, is I'll step back onto the stage behind the podium. And if anybody wants to stop by and talk to me one-to-one, questions or comments will be welcome. And that'll be an opportunity, probably in a few minutes if no more questions come in on the chat. So we'll wait briefly. Otherwise, I should thank you for your time today. I was about to say this afternoon. I suddenly remember that, of course, wherever you are, it could be any time of day. It's an interesting factor with virtual conferences like this that one easily forgets the time is different for different people. So saying good morning, good afternoon, good evening is increasingly meaningless. But I have to say to the organisers of this event that this is the most interesting virtual environment I get worked in for these conferences, and I think it's quite exciting actually. I thought it was a gimmick when I first looked at it, and it's all a bit clever, but actually they kind of make sense. So so congratulations to them on choosing a good platform. Okay, I'm going to step back now from my presentation, and I will be at the back of the stage if anybody wants to come and talk to me. Otherwise, enjoy the rest of the conference. And I'll say goodbye for now.
If you found this video informative, make sure to subscribe our channel. Click the thumbs up if you liked it, or leave us a comment on what we could improve. If you are looking for a job in the embedded industry, or you've got one to offer, drop us a mail to jobs@embo.io. That's jobs@embo.io, and we'll make sure that you match up. My name is Stefan Bückelmann, and as long as you keep watching, we'll keep covering the internals of the embedded industry.